Okay, so like I was saying, this is just a continuation of last chapter, still having to do with maps, latitude and longitude, still fair game. But the first thing we're gonna be talking about is mapping a field. So when I say a field, what's the first thing that pops into your head? A field, what do you mean, a field? Like out the window, like where the deer hop around in a field? That kind of field? Huh? Where the flowers, is that what you said? Or where farmers farm? Yes, absolutely. So a field where crops are growing. Or a football field, right? We went up to the field yesterday. That's what everybody kept calling up to the field. So you guys know the general gist of a field, but how about, have you ever heard, like, how about last year in science, a field of view? What about that? Yeah. You need a packet, what the heck? How about a field of view? Do you guys remember that from last year? Not at all. No, that's the one. Do you remember a field of view last year? You do? What were you working on when you heard field of view last year? What were you working with? Oh my goodness. How about the microscopes last year?
Oh, yeah.
Oh, yeah.
I was gonna say that.
Well, you were. So in the microscope, what was the field of view?
Like 20 feet.
It's what you could see. It was what, in the microscope, it's whatever was in that little circle. Sometimes you could see like just a little specimen with a lot of white space, but if you zoomed in your field of view, you're still looking at the same thing. But instead of being just a little dot, it filled up your whole field of view. So field of view is whatever you're looking at. So in this case, a field is still, it's kind of like that idea. It's whatever you're looking at or whatever you're measuring. So this is the first vocab word there, right on the page, was it 10-4? A field is a generic term for anything being measured. So it doesn't have to be the mountain out in the distance. It doesn't have to be the football field in front of you, but it could be. It's whatever you're measuring. So a person might be interested in measuring the temperature over a whole like town or a whole city or a whole state. They might be interested in measuring how high a mountain is, but whatever you can measure, that's going to be the field. We're going to be on these fields drawing iso lines. Iso lines, have you ever, here, that's great. Oh, it was right now where your foot is. Hang on, gotta help you.
Oh, darn.
It is, I was iso line, what do you hear when I hear you say, hear the word iso line? You see iso and line, right? You guys know what a line is, I don't need to find that. A line? I can't even describe it, hopefully you just know what it is. How about iso? How does iso, we've heard that prefix before.
Separate.
Separate, like if you isolate, it's going to be keeping things separate. Any other time you've heard ISO? Huh? Yep, we just said isolate. How about what else?
The gun and powder.
ISO what? Isopod? Is that what you said? I don't know what that is. Do you know? It's like a what? Oh, I don't think it's isn't that an arthropod? No, okay. I heard, this is the second person who told me it's a gun. Is that an abbreviation for something? Yeah, I don't know either. Like, is it all capitals when they? Yeah, so I'm guessing that's an abbreviation for something, so I don't know what that stands for. It may or may not apply. How about isosceles? Yeah, you ever heard of an isosceles triangle? Yeah, you should have. It's a triangle that has this two sides that are the same. Or how about if you run an ISO play? None of you? No, okay, none of, huh? And what's that mean, ISO and basketball? By yourself, so again, we're isolating it. So I was talking about football, but apparently it's one in basketball too. I have an isometric workout. Has anybody heard of that? Isometric workouts are when you just focus on one body part. So you separate just your legs this day. So you do a whole bunch of leg moves, or you do a whole bunch of arm moves, but you don't mix the two together. So isometric moves are just separate, the same thing all the way apart. So iso actually means to separate into same. And lines are going to be lines that talk about, or that are just lines that separate the things. So isolines are lines that connect places of equal value in a field, or they separate them depending on their values.
Oh, no.
What? So these iso lines are going to be lines that are connecting places that are the same. So basically, we're going to be isolating values that are the same. And we're going to be isolating them with a line. So there's some examples of iso lines. So we could draw what's called isotherms. Therms sound familiar? Like thermostat or thermometer. So what do you think isotherms are?
By yourself, cold.
Lines that connect points of equal temperature, I think is what you're implying there. Kind of, so the same temperature. Isobars, not places where you go to drink, but barometric, so that's where the bars come from. Barometric pressure is another name for air pressure, so you've probably heard of that on the weather reports. Basically, anything you can get a measurement for, so we already did temperature, we already did pressure, but anything you can measure or count can be drawn on a map with these lines that connect areas of equalness. The Weather Channel loves this stuff. Because I'll show you, you've seen it before. Oh, line? So what you said? Like I'm lying? Oh, the Weather Channel doesn't lie.
Oh, yeah.
Okay, oh man. So have you ever seen a map that looks like that
Yeah.
on a weather report? That is just an iso line map. So this was weird. This is a Friday indoor heating and cooling forecast. I know, right? So instead of just giving a map that shows temperature, they give a map that shows who's heating their house and who's cooling their house, and then the people in between. Basically, it's just it's cold here and warm here situation. But you've seen maps that look like this, and I know I've been talking about lines, and you're like, Ms. Ritzel, aren't lines as whole like sections. But if you were to just draw on the outsides of these color blocks, I know I just screwed up a little bit there, but bear with me. You see that it's really just a map that has a bunch of lines in it, and they color coded the spaces. So it's a map with lines, and then they make it easier to read by color coding it. Because if they didn't color code it, the map might look more like this, which just looks messy, right? But again, if they had color coded it, and I can't color in very easily, so this whole section, and then pick this whole section, you can see it's still the same idea. And I know you can't quite see it up there because it's not colored nicely. It's the same idea, it's just not color coded. This is what the scientists would use, and then they would color code it for the news to make it easier to read for everybody. This, in this case, it's isobars, so we just said that that's equal air pressure. Air pressure, which you're going to learn later this year, has a lot to do with the weather. If it's high pressure, like areas, this kind of high pressure up here, it's typically a nice day. And low pressure, like these numbers here, it's typically a crummy day. Hurricanes have very, very low pressure, so very crummy day. But anyway, we'll learn that later on. But just now we're focusing on the map. As you can see, everywhere on these lines, so everywhere on this blue line here is 1020. Everything on this line is 1018. So these all connect areas of equal pressure. So these are maps. And so here's the next vocabulary. A map is a snapshot of a particular area. And just because the map ends does not mean the whole field ends. What that means is just because this is a map of New York State doesn't mean there's more, isn't more world out there. Just because the map ends doesn't mean the world ends.
Design stocks in the world, we have to discuss that.
I don't think so.
Content that is used.
Yes. All right. So what this means is, so here's another map. Here's another ISO map, and this one's extra weird. It's a map of aches and pains. So apparently someone went out and surveyed everybody who's complaining of aches and pains. And this is the map they got. Can you read it? Who's got the most aches and pains according to this map? Up there in the very tip of Maine. Who's got the least amount of aches and pains?
California, if not work.
California? Okay, I don't know where you get that data, but California.
Okay, right, pick up a delivery.
Yep.
For my fundraiser, 12:41, whenever the.
Yeah. Uh-huh.
You let kids in if I'm not
I
there.
can.
Thank you.
Perfect. So for whatever reason, California has the least amount. When this map was made, California was the first state to legalize marijuana. So that might have had enough to do with them complaining about, stop complaining about their aches and pains. I don't know, I'm just, what? Yeah, brainstorm, like, I apparently need a map because I can't think of those words. Yeah, that's just brainstorming. But the reason I show you this is, so they clearly only did the United States, right? Just because the map ends here, does that mean that California doesn't Canada doesn't complain? No, just because the map ended does not mean the aches and pains didn't continue. My guess is this pattern is going to follow the same kind of idea. Whatever's going on here is going to follow a similar pattern up there. So for some reason, this section will complain a little bit, these guys will complain a little bit more than those guys. Probably this section up here is going to be more red than everywhere else. So it's going to follow the same pattern. Whatever's going on is going to continue. We don't know for how long. Like it might spread out like this up in Canada, or it might just end right there. We don't know. Whatever's going on does not stop because the map stopped. But we don't know what it looks like outside of the map they give us, is what I'm trying to get at here. So just because the map ends does not mean the world ends. Is the moral of the story there. The next vocab word we have is a contour line. When have you heard of contouring or contour line? Makeup, right? Is that what I heard you guys say? Art class, yes, perfect, art class too. So I can't relate because as you're gonna find out later this year, I don't draw. My stick figures even look weird. For how, and I don't also do makeup, so I can't really relate there, but why would somebody contour their face? To give it more shape, to kind of emphasize the structure. So I've watched enough tutorial videos to see that they contour the cheekbones, or contour the nose or the chin, to emphasize the places that are sticking out, or to emphasize, like with your cheekbones, you want your cheekbones to stick out, so you emphasize that down here sucks in a little bit. Whatever. Contours kind of emphasize the shape of your face. And that's what a contour map is going to do. It's going to emphasize the shape of the land. So in this case, it's going to be showing the elevation. The contour lines are lines that connect places of equal elevation, and I also put a second bullet there for contour interval. Okay. So that's actually what we're going to be looking at for like the next week or so. We're going to be looking at these contour maps and ISO maps. So basically a contour map is just a specific type of an ISO map. Lines that connect areas of equalness. I have a couple of examples to show you. If I was just to put this here, and you look at the screen, don't look at what I have actually up here. If you just saw that, what do you see? You see the lines and the colors, good. Hopefully that reminds you of the maps I was just showing you. And what we have going on here, and for those of you who can see what I have, it is like supposed to represent a mountain there. So you can see we've got, like if you were down here, you could walk up this mountain and here's the peak of the mountain. But when you look at it straight on, you can see that it is just a flat shape. Like you can take that mountain, holy cow, what's going on? You can take that 3D shape and represent the elevations, but just by drawing those lines. And you can even see the lines, like the outside of each one of these is the lines. And then they just color coded everything that would be on that line. So these are what we're going to be drawing, these flat versions of hills. So there's rules for this. And I just want to show you the next page. The next page, if you look in your packet, you'll see, and I don't want to do this yet, I just want to show it to you. This is what the map will look like before we draw lines on it. This is a map and it's got all these numbers are elevations. So somebody walked all around a place and measured the elevation of each location. We need to change all of these measurements into a map that's going to end up looking like this. No, thank you. Why do you say no, thank you? Looks really, really hard, right? It looks like a pain in the butt. It looks like it's going to make Hayden want to punch himself in the face again. It looks overwhelming, right? There's a lot going on there. I'm going to tell you it's actually really not that bad. And I think some of you are still going to be annoyed by it, but I think most of you are going to actually find it I wouldn't say fun, but the most fun you can have in earth science.
Just like bingo.
It's not like bingo, it's like connect the dots. I actually call this connect the dots for slightly older kids. So it's going to be very similar to when you go to a restaurant, you get a kid's menu, and there's a connect the dots on there. And you connect all the dots and you make yourself a picture of a cat.
I like the elephant ones.
You like the elephant, okay, so I will say elephants from now on.
Yellow crayon.
Okay, so Hayden at least knows what I'm talking about. So we're doing the connect the dots. And just like doing the connect the dots at Olive Garden or wherever you are, there's a few rules to follow. Now, instead of in normal connect the dots, you start at 1 and then you go to 2 and then you go to 3 and then I think you get the idea. Well, for this connect the dots, we don't go in order because ISO lines don't go in order. They connect areas of equalness. So instead of going 1, 2, 3, 4, what we're going to do is connect all the different ones and then all the different 2s. But even if we did it like that, there's going to be a lot of lines. And that's where this contour interval comes into play. From the notes we just took, what does contour interval mean? So from the notes we just took, it's the distance in elevation, and then I put in parentheses what the lines go up by. So we don't have to go all the 1s, all the 2s, all the 3s. We're going up by 10. So that means you're going to start at 0, draw a 10 line, then a 20, a 30, a 40, a 50, 60, 70, and an 80. So it doesn't mean we do all of them. There's not going to be 80 different lines on here. There's only going to be 8 different lines or something like that. What are you confused about? Because we're going to draw them. Our job is to draw the lines. Now there's rules for drawing lines. So if you go flip back to the front page, right here it says drawing ISO lines, and there's going to be 5 rules. So flip back 1 page, we're going to do the 5 rules, and that's probably as far as we're going to get today. That was my goal, was to do the lines today, but I'm thinking we're going to run out of time since we only have 11 minutes. We'll try. Let's keep going. Let's be snappy. All right, so Zoom, I need to share my screen. All right. So rules for drawing ISO lines. The first rule is ISO lines connect points of equal value. So I already have the word ISO line there. All you have to do is write connect points of equal value. So again, not 1, 2, 3, 4, but all the 1s, all the 2s, or in this case, I connected all the 10s. All right, rule number 2. Mrs. Ritz. Yep. Okay, bye. Victoria, it sounds like you're going home. So this will be posted on Teams if you want to get the rest of the video. All right, rule number 2. ISO lines are gentle curves or gentle curving lines, no sharp corners. Just like when Hayden's making the elephant at the Olive Garden with his yellow crayon. The elephant will come out looking funny if this is how he connects his lines, with these sharp corners. The third rule, and this one goes back to the fact that the world doesn't end when the map does. Somewhere, these lines will connect and make a closed curve. Even though our map might cut that curve off, somewhere in the world they connect and make a circle shape. So basically, the rule here is you either connect the lines and close the loop, or if you can't close it based on the data, you take the line to the edge of the map. And rule number 4, honestly, I think this is the most important rule. ISO lines never cross. If they crossed, like they do in this, I'll actually let you guys finish writing. So in this case, since this is a temperature map, if this red line was drawn the way it is here, which by the way is incorrect, it would mean right here where they're touching is both 30 degrees and 40 degrees at the same time. It's impossible to have two temperatures at one spot at the exact same moment. It's either 30 or 40 or somewhere in between, but it can't be 30 and 40 at the same time. So you know when you're drawing these, if they cross, you've done something wrong. And rule number 5, ISO lines are usually parallel or have what's called a parallel trend. Basically means they're parallel-ish. They don't have to be perfectly parallel, but you can tell, basically it tells you if you have one line drawn, the rest of the lines are going to follow the same pattern. So you can see where this one goes up and then down. All the other lines go up and then down. It might not be perfectly parallel, but they will have the same general shape. So really, I don't think we have enough time to continue on the map. We could probably get one line done, but then I'd have to explain that again to you on Monday anyway. So let's just start fresh on Monday and call it quits here. Okay.